All right, hey everybody. Set too loud? How do we feel? All right. So my name's Johnny Klemmer, as you can see real tiny in the corner, and hopefully you're all in the right place. This is how I learned to stop worrying and love Autolayout. And real quick, before we get going, I want to show you some found footage. This is Apple engineers as they're coming up with the solution of Autolayout. And for anyone who actually knows what that is, it's from an old movie from the 60s called Dr. Strangelove, and I had to call that out because I pretty much just stole my talk name from the title of that movie. And real quick again, I just want to let you know a little bit more about who I am, kind of my history and path through iOS. So when I started out, it was iOS 6, iOS 7, and I was working on a big team. They were already using Autolayout. We integrated Storyboards into our app and adopted that heavily. We used Interface Builder primarily for everything. So there's a lot of context that comes here, kind of from my path. That's my preferred way of doing things. And so you'll see that in code examples we have later, things like that. Autolayout is what you need to love. You don't need to love Storyboards and Interface Builder. Hopefully there'll be some stuff in here that'll get you to love that as well. And a little bit about where I work. It's a company called Client Resources, Inc. We're based out of Omaha, Nebraska. We do a mix of IT staffing as well as custom solution development, a classic dev shop, if you will. It's a pretty awesome company. If you're interested in more, there's a website there. There's also a booth we have outside, so you can come and talk with one of our recruiters if that sounds fun. And what are we talking about here? Like, what is this? So if you're totally new and confused, Autolayout is basically just a layout system that you can use. It's all constraint-based to arrange your views. And this is important because there's iPads, iPhones, new size of iPhones all the time. We now have split views introduced. And basically, if you're building your view without Autolayout, you're going to have a lot of headaches or a lot of bugs. And so hopefully through this talk, we'll kind of introduce you to how you can solve those bugs and avoid them in the first place by using Autolayout properly. And again, as I mentioned, Interface Builder, Storyboards, we'll talk a little bit about stack views and size classes. Those are all awesome tools. At the end, hopefully you'll love them too. But I think a lot of people don't love Autolayout because they did something wrong and they were burned at some point. It burned a bridge for them. And so I want to highlight what not to do and also how we fix it. And so the number one thing I don't want you to do is avoid it completely. Autolayout is a super powerful tool. As I mentioned, it'll make your views and your screens adaptive for all your different users. And so the number one thing you don't want to be doing is leaving that unchecked. So in your storyboard or interface builder, if you're in a nib, you want to make sure you check that box. If you don't have it checked, you're going to be looking at the old way of doing things. So in that top part there, you can see basically laying out by frame. This would be the same if you make a view in code with like CG rect and initialize all four values. And then we also have a throwback to springs and struts, which seem really intuitive and easy, but again, as you build more complicated views and things like that, those will bite you as the screen changes and things like that. So first fix, check the box. It's pretty easy to do, and you'll be right rolling on your way. If you don't know where that is, it's in the file inspector menu, by the way. So I think a lot of people get to that point, but then they kind of slow down and they avoid it somewhat, I would say. And one way you could do this is by using a third-party framework. There's been a bunch over the years, Snapkit, Masonry, things like that, to do auto layout for you and build your constraints in code. Those are okay, but I think it's important to understand the core fundamentals of what Autolayout is doing for you, what those constraints are building and kind of creating on your behalf. Because if you don't, you can run into the same situation and it's going to be really hard for you to debug what's going on there. So number one, get used to the basics, writing it yourself, and then if you decide those tools are right for you, feel free to adopt them into your project. Another thing I see a lot is ignoring these guys. So Xcode does a pretty good job of giving you warnings and giving you errors, and these are basically guidelines that something's going to go wrong in your view at some point. So warnings are super common for essentially things that are not a huge issue. Your view probably won't break, until you go into a different mode, a different screen size, things like that. And so it's easy to ignore those. The errors is much harder to ignore. You'll see a bunch of red lines if you're an interface builder. You'll get those nice output logs. And what I really want to stress is that when you're running your app and you see one of those pop up in your logs, or you open up your storyboard and you see some little like yellow or red icons, don't ignore those guys. That's Xcode looking out for you. And if you do ignore them, you're going to get burned by it probably down the line. So a fix for that is to get rid of them. And there's one more thing. I think you're probably kind of thinking like, all right, I'm starting to get the trend here. We don't want to avoid it even a little bit. So as long as I'm using Autolayout, I'm great. But that's not quite true, because you can go overboard. And I don't want you to do that. And one way you can go overboard is by simply over-constraining. So we have this nice red square, or red rectangle in the middle. And you can see on the right side all these different constraints I've set up with it. There's 9 of them total, and if we go ahead and look a little closer at what those are, these are pretty much all the possible constraints you can have. So if you're really new to Autolayout, I'll quick walk through. We have basically a few different types. There's alignment, which you can see at the very top, align center X and center Y. We also have some size ones that are related to width, aspect ratio, and height. And then finally we have our leading, trailing, and top-bottom. Another interesting thing to note here, if you've used anything before the Xcode 9 beta, you're probably used to seeing stuff in there like bottom layout guide, top layout guide. Those have changed, so as you install Xcode 9, probably here this week, you're going to notice this new safe area, and that's a checkbox you can enable or disable, but moving forward in Xcode 9, they've deprecated the top and bottom layout guides. This is the new way to do things. I think it's going to be really awesome. And really all you need to know is that it'll automatically upgrade for you, it'll automatically upgrade all your constraints for you, and it's backwards compatible. So as long as you're compiling with Xcode 9, you should get this support on all of your old versions, even if your app needs to support iOS 10 or iOS 9. And another thing you can go overboard with, we're probably all pretty familiar with MVC, the massive view controller joke going around, but there's another one you gotta look out for. And that's massive storyboard syndrome. And so I think a lot of people don't enjoy storyboards because they end up being really slow and they take a long time to load. And so what's important to remember when you're using storyboards, especially if you're using them in a larger team, is that there's a lot of tools you can use to keep your storyboard small, still get the benefits of seeing how your app is kind of architected and laid out without necessarily getting burned by massive storyboard syndrome. And if you're not sure what that looks like, it starts out with something like this, and you're going to stare at this guy for a little while, and eventually, hopefully, without an Xcode crash, you're going to see something like that. And as scary as that is, that's a real screenshot from a real project that I worked on. And I don't blame anyone for this. That's a classic lack of understanding, but at that point it is impossible to reason about your view layout. You can't follow those segs, you don't really know what's going on inside your application, and that's really one of the best values of storyboards, is that you can see the flow as you move through your screens. And so the biggest way I like to combat this is with storyboard references and breaking out a storyboard pretty much as small as I need to. So if I have 2 or 3 views, at that point I'll probably make a new storyboard, and I like to keep each one kind of localized to a feature or a flow. So I could have a larger picture that we'll see later of the structure of my app with maybe just storyboard references. Then I'll have other storyboards that'll contain those features, and you can break it down as much as you need to. A big common thing that you'll run into here is if you have shared views. As you can see in here, there's a lot of setup and logic that's shared between each of these scenes. That's a good place to use nibs. So if you just have a view that you want to kind of drop in, you can use container views inside of your storyboard, and then you can drop in a nib into your project, set up the view how you want, and then just hook that up to the different areas that need to use it. So that's another good tip to keep in mind. Another thing I want to talk about before we move off this topic is if any of you work in a team, another thing you've probably ran into storyboards a lot is merge conflicts. And honestly, there's no good fix for that. So the only two pieces of advice I can give you is when you're checking in your code, be conscious on behalf of your team that you're not checking in that just one line at the top of your storyboard, because anytime you open it, Xcode usually finds a way to just regenerate an ID, and you're going to have a change in that file, even if you didn't touch anything inside the the storyboard. Your source control will pick that up. So not checking that in if you don't actually have storyboard changes will help for the next developer who actually needs to change that file. The second thing is, like I said, breaking out into smaller storyboards and honestly just talking and communication with your team is what I found the easiest way for us to combat that. So if we know that we're both going to be working on a feature and what we think should be the same storyboard, we'll break that out into two different storyboards, or however we want to set it up. Maybe we'll name one 2, and then once both of us are done with our code, it's super easy to just copy and paste a scene into the main storyboard. So if you feel like those should be combined later, do it after both of you have worked on your pieces separately. And kind of along the same vibe of what not to do, I want to talk a little bit about debugging, because if you've ever seen those warnings or errors that I talked about earlier, the way Apple tells you to debug it is not very helpful. And so if you've seen one of those, it looks something like that. Don't worry about reading all that nonsense up there, but that's the general basis of what one of these will look like in your command line log at the very bottom. And this first highlighted part in the white there, that's basically Apple trying to give you some helpful advice. Then you'll have this middle section. This is listing all the different constraints that are set up that may or may not be related to what went wrong. And then ultimately at the bottom here, you'll have the actual constraint that was broken and probably why your view doesn't look the way you want it to. But I want to take a step back and look at what Xcode tells you to do. So they say probably at least one of the constraints in the following list you don't want. And I think they started off very clearly that this may or may not work for you. And then they go on with try this. They don't say do this because I think they know it might not work. Just give it a shot. Just try it. And then they'll continue and they say, hey, look at each constraint. Try again to figure out what went wrong and what you didn't expect. And then ultimately, the best part, just find the code and fix it. And so if you're new to auto layout, and this is kind of this weird, challenging thing to you, I think this is probably the worst message you could get, especially when they follow it with this really confusing syntax of stuff. So if we kind of look at that, all of these areas in red are very vague and just kind of like, maybe this will work, maybe it won't, maybe this will help you. So we're going to kind of restructure how you should look at these error messages, and you'll start by ignoring this first part. I want you to try this instead the next time you come across one of these. So first step, track down the offenders. And what I mean by this is find the constraints and find the views that are sort of troublemakers in what you're building. So at first, you're probably going to need to track down that scene. And sometimes that can be confusing if, say, you're starting up a project you haven't worked on in a while, and you just scrolled through logs and all of a sudden noticed this was in there. So there is at the bottom of that first message something that talks about putting in a symbolic breakpoint. You can do that by going into Xcode, clicking on the breakpoints, add symbolic, and then you just paste in that symbolic breakpoint's name that they give you in the error message. What will happen there is you'll get the breakpoint just before the constraint is broken. That's not going to be super helpful to you other than knowing as you're clicking through your app or walking through the views where this roughly occurred. But then you're just going to see a list of kind of memory addresses and things like that that aren't super readable and helpful. So the first part is just getting to where you need to go. And once you're there, you can start to reason about your layout. And what I mean by this is take a step back before you just start changing constraints and moving things around, and try and really get an idea of what this view is doing. I think a big part that helps when you're building layouts is starting first, looking at the layout, looking how views are positioned. If you need to support iPads, for example, thinking about how should this change once I go to an iPad. And once you start to get that reasoning together, once you start kind of knowing, oh, this is what I need to be building, this is how it should look and move and react as the user does things, maybe as data loads, that's when you're going to start to understand what could have caused these things to break. Maybe, oh, I'm running it on a new device, and I should be looking at the height changing because I'm on a taller screen. So unfortunately, step 3 is still the same. You need to find that constraint or constraints, and you got to track it down. But there's a couple of tools that can help for this that I personally like to use. The first is there's a preview mode that I'll show you later, but when you're right in Interface Builder, you can open that up and then you can set up as many devices as you want and look at them side by side. So you could have your iPhone 7 in portrait and in landscape, and maybe an iPad in split view, and all these different orientations, and Xcode will render all of them simultaneously, and you can have that up side by side, so as you change a constraint over here, you can see the impact of that across 4 different screens. That's super helpful if you don't want to stop, rebuild your app, check what changed, maybe go into the iPad now, check what changed. It's going to give you a much quicker cycle of finding and fixing that constraint. Another one is the 3D Layout Builder, which again I'll show you later in this talk, but the 3D Layout Builder is awesome because you can basically split apart or blow out your entire view, and you can click on every single view in your hierarchy, and you also can click on a ruler just as if you're an interface builder to see where those constraints are laid out. So that's going to be super helpful if you're basically not sure which constraints are live and active at this moment in time. I like to navigate and kind of look through my constraints that way because I'm more of a visual person. But the final resort, if 1 through 3 don't work, is you need to dig around in that messy stack trace. And I'll give you a little hint and tip to make that less painful moving forward. But unfortunately, this is still kind of what you might end up needing to do. And then the final resort, if that doesn't work, is reset and redo. And what I mean by that is you might be in a situation, especially if it's over-constrained or it's just impossible to reason about all those, that you kind of need to start from ground 1. That's not always so bad because if there's a lot of broken constraints on a screen, chances are that if you've spent some time in step 2 and you've kind of reasoned about how it should work, when you go through and build it the second time, you're going to have a much better idea of what you need to support, what you need to change, what constraints maybe shouldn't be there to begin with, and that should hopefully help you to not stay in this cycle. So I mentioned I was going to help you with that stack trace. And the confusing part about it is these lines at the top. And if you can't read that, basically what we have is a layout constraint, we have a memory address, and then now we have something new where the constraint actually has a nice user-friendly name. Then we also have a nice user-friendly name for our view, and it tells us that the width equal to 300, that was the constraint, is the one we're looking at. So how you can get those names up there is by setting the constraint ID. So basically all I've done is double tap on a constraint in Xcode. Right at the bottom you'll have this identifier tab, and you can go ahead and type in whatever name you want there. You could leave this in if you want, or you can just use this for debugging purposes, but that's going to be super helpful if you're just trying to get through a list of 10 or 15 constraints to actually have a searchable string. Another nice part of this is you can search for these in Xcode, and it'll come up in both a storyboard or interface builder as well as it would in code. So don't feel like just because I set it in some UI view, I won't be able to track that view down later. You can get to it. And then the same is true if we want to have a UI view or any other type that supports accessibility. You can set that up with an identifier under the accessibility tab. And what that'll do for you is give you, instead of a UI view and some random memory address, it'll go ahead and give you that nice red view name that you previously didn't have that information. So that's kind of the gist of what not to do, but there's a little bit more to auto layout that I haven't touched on yet. And I think personally for me, this was something I overlooked for a very long time. And that's one step back, content hugging and compression resistance. So what these are priority values that you can set. And if you're not familiar with what priority means in auto layout, it's a number between 0 and 1,000, and it basically tells auto layout how important is this constraint you're setting. But what's interesting about content hugging and compression resistance is they compete, so to speak, with your constraints. So you'll often see these set at like 250 or 750, and a lot of people don't touch them, and that's perfectly okay if you can build your views without them. But sometimes you can save on writing 2 or 3 or 4 constraints by using these properties if you understand what they do. Also, you can sometimes fix some bugs by using these properties. So we're going to jump into a real quick demo to kind of show you what that looks like within Xcode. And let me just get you a nice screen. We'll pull this over. Just need to find my display there. Beautiful. So what we have here is a real simple view. This is inside of Interface Builder if you're not familiar. And we have a couple of labels that we can look at here. One that's going to be demoing kind of what compression resistance looks like. Another that it will use for content hugging. So it might be a little hard to see at first, and we'll go ahead and zoom in to hopefully make this clear for everyone. But all I'm doing is clicking on this ruler tab and clicking on my label, and then we can kind of zoom in and take a look at what these constraints are. So currently we have some alignment, that's just to keep these out of our way, and we have a width constraint that has this nice dashed line about it. That's letting us know that it's not at 1,000 priority. So anytime you have something underneath 1,000, it'll give you that dashed line, essentially letting you know that this might be broken by another constraint, another view, a change that you might make in code or something along those lines. But ultimately down here we have our compression resistance, and you can see this is set at 1,000. So I have my width of 100 and I have my horizontal compression resistance of 1,000. And what these two are doing right now is it's preventing this view that we have on this other side from getting smaller. So if I was to change this down to a number beneath width equals, and width happens to be at 999, you can take my word for it. So if I go ahead and go to 998, what happened over on the left here is that our label shrunk. It got compressed. And so compression resistance, really the only thing you need to think about it is this is me pushing back on other constraints, maybe width, maybe it's leading trailing, but essentially I'm saying the internal size of my label is more important than the constraints outside of me. And the way you set that up is just by lowering maybe the less important constraint or raising the compression resistance. So then when we talk about content hugging, it's basically just the opposite. So content hugging is this nice little gray box that we have, how close we want that to be to the text. So if we look at the constraints we have here, there's a leading and trailing of 50. You can see again our leading has a little bit of a lower priority, and that's why we have a dashed line on this side. And then ultimately our content hugging is left at the default 250. So if we jump into this, we can see that this is set to a priority again of 999. So if we go back to our label and we say that we want content hugging to jump up to, say, 1,000, we'll get our changes going on over here. And it's a little hard to notice, but what's happened now is that gray box is shrunk horizontally very tight to our label. And we also have moved a little bit further to the right. And the reason for that is that it decided it was more important for that solid 1050 pin to the right edge than the other 50 that was a lower priority on the left. And so what you can get here is different behavior where in some situations maybe I want it to be perfectly centered, but should the text need to shrink, I can use content hugging to achieve that. And an area where you'll see these come up a lot is in stack views, which we'll talk about next, because essentially stack views have some weird kind of things that they do based on content hugging if you're using some of the different distribution properties. And so we'll jump into that moving forward right now. So one thing before we get into this part, I want to kind of let you guys know we don't have to wait till the end. So if anyone has a question and they want to jump up and ask it, raise their hand, anything like that, before we switch out of this area, feel free. Otherwise, we can go talk about some stack views and size classes. Sound good? All right, let's roll. So we'll start out first with stack views, and I'll post the source code after if you want to tinker around in this project. But what we have here is a nice little screen that has some, titles and some content and things like that. And if we go ahead and run this app to kind of get a feeling of what it looks like, I'm going to go ahead and put it in an iPhone 7, so hopefully it'll fit on our screen. We'll get a nice cool air. This is the fun of betas. All right, so now we're rolling. And what I want to kind of show you first is how this screen reacts and adapts and changes, if we can ever run it. Oh, come on. Xcode restart, that's something you need to learn. Yeah, that's what I tried last time. Yep. All right, let's roll. So I'll show you both examples in this app of what we can kind of do in this screen. But stack views are new, in case you didn't know. If you've been avoiding them, Springboard. We'll give it one more try and then we'll just talk about it. Hey! So here we have our sample app, and it's just a simple tab bar layout. And here's the screen that you're seeing behind it. And so what we have is section 1, 2, and 3. And we have a nice little button here where if we want to collapse these different sections, we can. And if we wanted to open all these sections, and that's now taller than the screen, we have this in a scroll view so we can adjust it. We also have some nice features that we get where as we rotate, everything kind of stretches out, lays out differently, and we can get all the same functionality that we had before. And how we built this, we'll dive in real quick and kind of look at the hierarchy of one of these. So hopefully that's plenty readable. But what we have is a handful of nested stack views here. So at the top, you'll see our view. I can go up a little bit higher for you. And that's just the main content view of our app. We have the safe area that I mentioned before that's new in Xcode 9. And then we have that scroll view. And so that's the outermost layer, which you can see if I go ahead and collapse this, that our view is contained in. Then we have our list of horizontal stack views. And you can think of this as each of those sections. So it contains the title, the button, and the label. If we open that up, and we open up one of the sections, we can see we have a horizontal stack view that contains all of our information related to the title, which it might be helpful to see over here. So we have vertical stack views so far that are basically going to be stacked as you would expect vertically. And now we've added a horizontal stack view because we want this placement of a label next to a button. And then we can just leave that label loose within that other stack view because we don't have any other special things we want to tack with it. So this setup is exactly the same for the other ones, but one thing I want to point out to you as we're looking in here, there's very little constraints. I have a constraint here for the width and the height of my button, but otherwise all of this is being laid out by the power of stack views, I would say. So if we kind of look at what this does and what this looks like, I can click on a stack view from my side over here. Let me get back to a reasonable zoom. And in this attributes inspector, you can kind of look at all the different properties of what stack views have. So I've already touched on this axis, this idea of we can control whether it should be laid out horizontally or vertically. But there's a couple other things you need to know about, and that's alignment, distribution, and spacing. And probably the easiest of those is spacing. Essentially, if you want any sort of constant spacing within your views inside of a stack view, you can chuck a number in there. Alignment is also somewhat straightforward. There's this concept of fill, which is basically stretching everything out because I want to fill the entire stack view. But you also could have it aligned to the top, to the center, to the bottom, or if you're dealing with a lot of text, you might find those first and last baselines useful. That's going to basically line up to either the first baseline, the very first line of a text, chunk of text, or the last baseline, which would be the last line of the text. Then we have distribution here. And what distribution will do for us is basically a handful of different things. So fill is the one I'm using. That's the default when you use a stack view. It's just going to distribute everything across your entire view. Fill equally is going to basically set properties, and this would be easier to look at. It's going to now try and make each of these two things inside fill evenly. So now both of them have 1/2 of this total, width that I have available to me. So that's kind of useful if you have a handful of views that you want laid out in a way where everything gets an even chunk. For our example, we basically want this label to grow as much as possible and the button to stay kind of pinned in that top right corner, sorry. And so then we can move on from there and see fill proportionally, which if we click on probably won't look any different. Where fill proportionally is going to be useful is basically if you're having a setup of different things that you want to fill out, let me think of a good way to say this, in a way that's sort of evenly spaced out. But it takes into account that content hugging that we talked about earlier. So if a view wants to basically be larger or tighter, it can, and it'll sort of try and evenly proportion that along the total available width you have. So to be honest, that one is probably less common. I don't think you'll see that as often in the views you need to build. Equal spacing and equal centering are going to be really good if you have objects but you want them to basically not be totally tight to one another. So equal spacing is this idea of if we click on this, it'll put an even amount of spacing between our views. If we had a third view in there, there'd be an even spacing between each of them. But then if we were to use the other spacing method here, which is equal centering, what this is going to do is if we have views like section 1, which is wider than the button on the right, it's going to look at that center of each of your views. So section 1, it'll look right around that eye, and the button will look right in the middle, and it'll position those centers across. So sometimes that's just a different behavior that you might want kind of included in your views. So we'll go ahead and change that back to what it originally was. That is, in a nutshell, stack views, but there's one other thing I kind of want to talk about here. So we had some functionality as we were tapping that button that was opening and closing our different stack views. And that functionality is very little code. So what we have here, that's a little too big. What we have here is just a handful of outlets and actions. And all we're doing is getting each of our UI labels, and then as they tap on each button, we're setting it to hidden or not, and then we're also changing that button title to be a minus or a plus sign. But what's interesting is that stack view gives us this functionality out of the box of anytime a view is hidden, it's going to be completely collapsed within whatever layout you have set up. So if you have something like a form, something like a view like this, concept of drawers, anything where you're kind of dynamically opening and closing views, it's oftentimes something that needed to be accomplished before stack views by setting constraints either in code or through outlets, and then manually setting and growing those constraints. So changing your height dynamically based on a button tap, for example. So stack views is giving us that out of the box of essentially saying, hey, I know when this view is hidden, I can render it differently. So if we kind of look at what that means in our stack view over here, each of these labels is in this horizontal stack view. So as I hit the minus sign, this label is going to completely collapse horizontally and no longer be in sort of our visible view space. And we get that nice clean animation right out of the box. You can animate those changes as you hide and show properties by wrapping them in a simple UI view animate. So you can get a lot of power out of stack views, both in terms of just laying things out in a nice and clean way with a small amount of constraints, but also I like to keep them kind of in the toolkit, so to speak, for areas where I have views that need to sort of adapt, grow, shrink, things like that. Another thing that's kind of interesting here is if you've worked with scroll views without stack views, you essentially have to basically pin everything in the direction you want to scroll. So from the top of your scroll view to the bottom, you're going to need to make sure that your scroll view knows what that intrinsic content size is. So you need to know, my scroll view is 1,000 pixels versus 2,000, and that's what the scroll view uses to know how long it should be able to scroll to the bottom of the content. So that's a good area to know. With my stack view, I don't have any kind of special constraints set up. So it's getting all those sizes for me right out of the box. Basically all I have set here is a set width because I don't want to be able to scroll horizontally. And then I'm pinning top, right, bottom, left, right, top, bottom. But again, I'm not pinning anything inside of all those stack views. All of that I'm getting out of the box. So if I was to now change this layout and add new labels and things like that, I don't have to sort of redo every constraint top down. So that's a good area to know. Before we continue, anyone have any questions about that? Yeah?
If you hide the storyboard, will it hide it? Like if you said it's hidden on the label, will it actually hide it in stacking?
Yeah, so it will, if we go ahead and do this, I'm assuming is what you're talking about? So yeah, it goes ahead and it will render that appropriately. Because we're in a scroll view, it's doing some weird stuff or kind of push that off the top. But yeah, if you had something that's hidden by default, a lot of times I'll actually check it hidden in the storyboard. But that being said, if you want to be able to, again, like kind of reason about your view, a lot of times you might need to sort of uncheck and see everything in its expanded state.
Does that also work for like codes if you change it hidden in Swift or whatever? Would it automatically, would you have to re-render it somehow?
No, yeah, so you're going to get that for free. Basically all I was changing in code is that is hidden, and it'll know that it needs to update the layout accordingly. So we'll jump into size classes real quick, and what I want to show you here is basically the other part of this view. And what we have is, this is also using stack views, so you can see we have a static image across the top, and then we have these three colored, kind of boxes that are set up currently in a horizontal stack view. But based on rotation, we might decide that it'd be cleaner for the user to see that in sort of that vertical format. And so size classes is what allows us to do that. If you're not familiar with what a size class is, it's essentially a variation of width and height. And Apple kind of maps all of those width and heights by compact and regular for all of their different devices. So iPads might be a different size, but then as you put it into like a split view, it'll change to maybe a compact width, for example. And the way you kind of access all of those is with these menus at the bottom here. So you can see currently we're viewing as an iPhone 7, which has a width of compact, but a height of regular. And as we change, maybe we go look at an iPad now, we can see that we have a width of regular and a height of regular. And then additionally, we can change to a split screen, maybe a 1/3, and you can see our width is now compact compared to the full size of the iPad. So using size classes basically just means understanding how I expect my view to change as I go into these different settings, and then appropriately changing my constraints. So the only two constraints I've changed in this view to get this behavior is this height constraint. So I want most of the time that image to be 200 points tall, but if I ever have a compact height, for example, a landscape iPhone like we saw, I go ahead and shrink that down to 125. And the way you add these is just by hitting these nice little pluses, selecting which variation you want, and then adding the variation in this list. And then if you decide you didn't want it, you can go ahead and remove them. You also can set that up by hitting vary for traits down here and start to introduce variations by different things. It's just another way to get to the same kind of behavior. There really isn't any differences there, other than you can use these normal pinning menus that you might be used to. So the other thing that we saw is we saw that stack view is changing as we rotated our device. And so how we operate that is you can actually change the axes from horizontal to vertical based on a new size class. So as you can see here, I set up that I want it to be in that vertical format when I'm in that compact width, but a nice tall height. And then the rest of the time I can leave it in horizontal because I'm going to have enough width to show all of my content. Obviously this is, you know, highly dependent on what you want to accomplish, but it should give you a good idea of kind of what those look like. Looks good? No questions? Cool, so we're going to go ahead and jump back to the slides here. So we've talked a little bit about stack views and size classes, and I want to leave you with kind of one final thought. You deal with your layout once. I'm not going to lie to you. Auto layout can be confusing. It can be strange. You can run into all those bugs that we saw earlier. Fight through those. Tackle them, because what's going to happen is you're going to build this layout to work exactly the way your designers and maybe your client wants or you personally want. But your users are going to deal with it forever. And so if you're skipping bugs, if you're allowing kind of weird animation or UI things to occur, those are going to be things that the users of your app are going to run into all the time. They're going to see those on maybe a daily basis as they interact with your app. So it's important to know that this investment you're putting in to get it to run on all of their devices and all of their rotations. A good example, if you haven't seen it, dynamic type is another super important area that has to do with this, allowing that type to scale for users with low vision. All of that stuff is important to keep in your mind when you're developing and designing these views, because that's going to be a reoccurring issue that your users are going to end up fighting against and ultimately maybe not using your app. And that's all. Thank you, everybody. So I think we have a few minutes if anyone has questions. Otherwise, I'll be around. Feel free to get a hold of me. I'll post both the slides and the sample app in the presentation materials chat. Yeah.
So one of the biggest issues I've had with Storyboard and Autolayout is consistent design across multiple views. So say you have an icon button that you want it to be 30 by 30, but you have other views where you're using it as well, and you're setting up those constraints. If your constraints are set up differently because, say, one person worked on it one week and the next person set it to 25.
Sure.
Identifying those and keeping those consistent. Do you have good some tips on how to consistently have size like that, and maybe padding and things like that? That's where I see most of my issues.
Yeah, so the question, if anyone didn't hear it, was basically around if you have an icon that you want to reuse throughout several areas and you're setting to sort of standard sizes. In that example of kind of the width and height, it's not too easy. You're probably going to have to set that in multiple places. That being said, if your image is a set size and in all of your image views you're basically using like a center, then it becomes a lot less important how that width is set up, because your image should look consistent across all devices. So in that exact case, that's how I tackle it. At kind of a larger question of I have these reusable components, how do I want to achieve a style across? That's where UI appearance becomes really valuable. So UI appearance is something you can use on pretty much any Apple UI element, and you can style it accordingly. So you could set up a UI appearance for a button, like a generic Apple UI button, or you could set it up for maybe your custom class that has some extra functionality, and then you can style that to certain colors and things like that and set a handful of different priorities on it. But that being said, when it comes to auto layout and how it interacts within a larger view, that's where you still need to use the constraints at that view level. So that could be an area where container views are helpful. If that, the setup of how that icon is included, you could maybe set it up once in that format. Yeah.
I'm just getting used to the IB where I'm more web space and working with CSS.
Sure.
It's really intriguing seeing how you achieve a lot of the same things with completely different internal tools. So two quick questions. One is, when I view my constraints, that example you showed early on with all possible constraints inside of my D&D inspector, it bugs the hell out of me that I can't cleanly adjust those in the order I want to, I would always do.
I see what you're saying, yeah.
Having tricks for that.
Yeah, so the way your constraints are set up is something that I think you just get used to. You don't really necessarily control them. I believe it's set up in the order that you add them, but that being said, I wouldn't necessarily count on that or fret about, how it's done.
Just get used to it.
Kind of, yeah. Second?
The second question is, in CSS, obviously, it's responsive to data design. We're used to saying multiple breakpoints.
Right.
So compact versus regular is still strange in my mind because obviously in the applicant system there's a lot of different compacts and a lot of different regulars. And specifically, I feel like, and I can't prove it to myself in that way, I have to prove it, but I feel like if you're like, say, at 2/3 versus half versus a third with like, different breakpoints that I always love and allows, it seems like some apps do adjust to different types of compacts slightly.
Yeah.
Is that correct? And so how would you achieve that?
Sure. So the question was basically around, the differences between like a CSS media query where it can be set up on specific resolution breakpoints versus, what we saw here with size classes that's much more generic. They're probably tackling that in one of two ways. Either they're doing it in an older way, where they essentially just actually look at the screen width and adapt accordingly, or they're setting up more complex constraints to basically see, as width shrinks, maybe I adjust based on an aspect ratio or something like that. So, awesome. Thank you again, everyone.